Artificial intelligence researchers at DeepMind have mastered Pong, chess, and Go. But some games are on another level.
The game of Starcraft II, one of the most complicated video games ever created. It is a real-time strategy game, which means that you don't take turns, you play, and you have to play fast.
Oh God, pushing this back in! He's gonna kill off MVP here! Oh, he kills off the mothership core! He is everywhere!
It was clear that Starcraft would be a great grand challenge for us to tackle using an artificial intelligence, the techniques we love, namely neural networks, deep reinforcement learning, and so on and so forth. My name is Oriol Vinyals, and I'm the lead researcher of the Alphastar project.
Alphastar is an artificial intelligence system that plays the game Starcraft II.
So the first element of Starcraft that's quite different is that you don't get to see what's happening on the other side of the board. That is what we call imperfect information, and is a key challenge that neither in chess or Go are present. Another key difference is that the pieces of chess, or what we call units in Starcraft, are created throughout the game, right? So you start with very, very few units, and what you're doing is deciding which pieces are you going to invest in creating next. And that's very important because at the same time you must counter pieces or units that the other player is thinking about without having perfect information. The first step of Alphastar is, can you predict where a human is going to click? What's the most likely move? So essentially Alphastar is gathering information from the game, where all its units are. It's getting all this data into not a program, but rather a mathematical entity that is called neural network that is able to then process all this information. We never hard-coded what this processing means. This was fully learned from first imitation learning, trying to imitate human moves, and later on self-play through the Alphastar League. And after this processing, many layers of computation of learned behavior at the top, there is essentially a single action that will be sent back to the game. And so this action could be create a new unit, create a worker, send this worker to scout, move the camera to this location. And that's essentially what Alphastar is. Every basically 20 milliseconds in the game, and every action you see here is a result of computation using this neural network.
By January 2019, Alphastar was able to beat 2 professional players, under special test conditions. But people wanted to see if it could reach the GrandMaster level, beating the best players at the full game.
What's quite critical is that humans are very creative at playing this game. So once we went online with this agent, we faced all sorts of creative strategies that we could not possibly have ourselves designed. So the very first game that we entered, we were playing against obviously someone we don't know. So it really was like a lot of adrenaline and a great moment to let people essentially experience what it is to play against such a strong AI.
Alphastar progressed by playing against itself, against a range of human players, and crucially, by playing against other AI agents.
We have this league of agents where all the agents are doing self-play in a manner that is perhaps a bit more advanced than what has been done before. And there we did perhaps the most research advances in the last few months, in which we discovered that it's not sufficient to have only one agent, that its sole purpose is to beat itself and its past versions of itself. It's very important to add agents that find flaws in the main agents, right? So we call these agents exploiter agents. And if you will, it's kind of asking for a friend to beat your current strategy, and maybe this strategy that is going to beat you is not a great strategy in isolation, but it's certainly going to help you become a better player. And that core idea, plus then some extra developments in imitation learning and reinforcement learning that we had in the project, created an artificial intelligence agent that can play the game of Starcraft II at a GrandMaster level. Actually, I used to play the game back in the 90s. I played quite seriously the first version of the game. One of the sad things that happened is that I kind of waited too long to play against Alphastar. So the team was really, like Oriol, you should play. At some point I decided, okay, I'll play against the agent. I played when it was just strong enough that there was no chance for me to win. And I just basically lost the window for me to kind of defeat the agent, sadly. So cool, victory. Not for me.
Alphastar has broken into the top 200 players in Europe at Starcraft II, playing the full version of the game with all 3 alien races.
We are here not trying to solve Starcraft, we're trying to utilize Starcraft for the purpose of advancing AI research, but be applied to any domain that utilizes artificial intelligence in any of its components and enhance, for instance, its robustness, its capabilities to do imitation learning from experts and other things that we deem super important and that Starcraft really let us test on one of the most complicated video games ever created.
Success in the real world is a little more complicated. Computer games can readily provide the data points an AI needs to master a challenge, but not every problem provides so much accurate feedback. The integration of AI into everyday life will be a much longer battle.